Welcome back to BAS 120. We're on Chapter 5, and let's talk about how an airline industry, example 5.21, might use expected value to help their business. Now, it's a little more complicated than this, but let's just, for simplicity purposes, assume that they have full price tickets at $560 and discounted tickets at $400. And let's assume that if they discount the tickets, the probability of selling them is 100%. They'll have no problem selling them at the discounted price. And the probability of selling them at full price is 75%. Now, should they discount them? Well, if we look at the expected value of, if they don't discount them, the expected value is 420. Now, the probability is going to change throughout the day, but we've made this a simple example. Since the expected value is greater than the discounted price, in theory, we wouldn't do any discounting. And down here, we just did a simple calculation of at what probability would it begin to make sense for them to discount the prices. So if you remember algebra, since this equation is 560 times x, right, my probability, and that equals, when does that equal 400? You can do some simple algebra, which I've done up here for you, that says 400 divided by 560. I just divided 560 by both sides to solve for x. That tells me that if the probability falls below 71%, then it may begin to make sense to do discounting. Very simplistic example, because obviously a lot more comes into play. Like if you could change behaviors. If people expect that you'll always discount, they might defer buying at full price. Lots of stuff, but it's just a simplistic example of how folks could use expected value, probably in a much more sophisticated way than this example, but they can use it for any of these sort of industries like airlines, like restaurants, cruise ships, hotels, where last minute bookings really help you, because if you understand the variable cost, the cost of taking the 21st person on a flight is almost zero. Right? It costs the same whether I fly 20 people or 21 people. So I can heavily discount that ticket and still make money at it. So that's an example of expected value. Let's talk about variance. This is example 5.2. Now the variance, of course, as remember, a little bit is how much our data varies from one end of the spectrum to the other. Now let's go back to our example of rolling the dice. So if I said to you, what's the average of rolling the dice? Anytime I talk about variance, you sort of say, well, variance from what? Well, we don't really have a mean, but we can come up with sort of a good substitute of the expected value, because we know the expected value. And again, these are just the probabilities of those events. And remember, the events from increase up to 7 and then decrease back down. And the expected value is simply the outcome times the probability. And I can sum all of those expected values up to get the overall expected value. So the overall expected value of one roll of the dice, what I expect, or what you could sort of call a pseudo mean or average, is I expect to get a 7. So now that I know kind of what our middle or expectation is, I can begin to calculate a variance by saying, well, let's compare the outcomes of any given roll. How far are they away from what we expect? So I just take my outcome, so 2 minus the 7, what I would expect, and that's a -5 away from what I would expect. 3 is -4, a 4 is -2, and so forth. Now, notice one thing, and this will be a recurring theme in variance and standard deviation as we measure. Certainly, if we average up all the deviations from what we expect, we're going to get 0, because what's going to happen is the negatives and the positives are going to offset each other. So we're going to accomplish nothing. We're going to say we can't say the variance is 0, because certainly we've got values that we know vary from the expected value. So mathematically, what we do to get around that is we square these differences. And remember, by squaring a number, we make them all positive numbers. Anytime I square a number, notice here, they all become positive. Now, over here, I just take my squared value times my probability, right? This is the squared variance distance. It doesn't happen very often, so I multiply that to take a weighted average of all my squared deviations from the expected value, add them all up, and I get a variance. And then if I wanted to get a standard deviation is simply the square root of the variance. But the theme is all the same. I'm looking at each one of my outcomes, seeing how far are they away from what I expected to get, or my mean, or my expected value in this case. I square the numbers because I can't have negatives and positives offsetting each other. And then in this case, I multiply it by the probability of that event happening. I sum them all up, and that's my variance. If I wanted my standard deviation, I would take a square root of that. So that's what a variance is. Hope that helps. We'll move on to other stuff in the next video.